Okay, so for today's pre-calculus problem of the day, we have a polynomial here. And so we're going to find the zeros, and then we're going to graph this polynomial. Now the graph, we're going to use WebAssign. So this is a problem from my WebAssign homework. And so for the graphing part, it's multiple choice. So I'll show you how to navigate that rather than graph this by hand like you could. But we'll use the multiple choice answers to kind of make this a little bit easier for when you're doing the homework. Now, zeros. What are the zeros? So when we say find the zeros of a function, we are talking about the x-intercepts. So we're looking for the x-intercepts. Now, how do you find the x-intercepts? Well, you set the function equal to 0 and solve for the x. So find the x's where this would equal 0. And this is a trinomial, a polynomial. And so probably the first idea would be to factor it. Now, you might not know how to factor a fourth degree polynomial. And sometimes you can't. Sometimes once you get past the quadratics, it gets a little bit trickier sometimes to factor these. But whenever you see a trinomial, and in particular, when the two exponents that you're given in the first two terms are one is double the other. So in this case, 4 is double what 2 is. You can really factor this. If it's factorable, you can factor it like it's quadratic. So in other words, if I gave you this problem and said factor that, probably you'd have no trouble doing it, right? Be x minus 9x plus 1. So it's just the standard problem from an algebra class where you need two numbers multiplied to give -9, and then they add to give, and their sum is -8. So -9 and +1. Easy enough. So when we have this situation where you have a fourth exponent and an exponent of 2, you can do the same thing, but you got to change. You can't use x and x because x times x, as you know from FOIL, multiplies to give x squared. That gives our first term. So we need two numbers or two terms here that multiply to give x to the fourth. So that would be x squared. And then the other part is just going to be the same. So when you see these higher degree polynomials, but we still have a trinomial, so three terms for the trinomial, you can factor it like it's quadratic as long as this first exponent is double the next exponent. So we could do the same thing if we had x to the sixth minus 8x cubed minus 9. That would just be x cubed minus 9 and x cubed plus 1. So as long as that exponent is twice that exponent, you can factor it as if it's quadratic, and whatever this term is, so x cubed, just a variable, not the coefficient, but whatever that is, x cubed, that will be what you have at the first of each binomial pair. So the other thing when you're factoring these higher degree polynomials to pay attention to is you can actually still factor x squared minus 9. So we're not fully factored yet. When you have a quadratic like that and you just factor it into its two products here, or the product, you can't not factor x minus 9 or x plus 1 anymore. But x squared minus 9 factors to x minus 3x plus 3. Now, x squared plus 1, you cannot factor. So if you have a plus here, x squared plus something, you're not going to be able to factor that anymore. But x squared minus something, you probably can. You definitely can. May or may not be worth it, but in this case, it certainly is. So now we need to set each of these equal to 0 and solve for x. However, x squared plus 1 equals 0 has no real solution. The only solution to that is complex. But here we get x equals 3 and x equals -3. So those are our two zeros. So those are our x-intercepts. Now, we're going to go to WebAssign in just a second. and look at the choices to graph. But a couple of things you might remember from algebra, maybe you've seen it a little in pre-calc, is you can at least get the basic shape of this. So we know that the zeros are -3 and +3. So it's going to cross the x-axis there. Also, so we know sometimes we have polynomials where the x-intercept just touches. Sometimes we have it where it crosses, like those. So here we touch the x-intercept, here we cross the x-intercept. How do you know the difference? Well, you know the difference because on one like this, so let's say we come down and touch at, say, 1. That would be x minus 1 squared. So this x-intercept is doubled. And whenever you have an even number, whenever the x-intercept appears an even number of times in the factored form, so you have x minus 1 squared or x minus 1 to the fourth, so on, it's going to come down and touch. If you have one like this, that tells you that it's either, so let's say that's 1 and -1. It's either x minus 1 or it's x minus 1 cubed or it's x minus 1 to the fifth. It's going to be an odd number. So since both of these x-intercepts have an exponent of 1, we know that it's just going to cross. It's not going to touch. It's going to cross. All right, so we know it's going to cross. The other thing we also know, the leading coefficient is positive. So when the leading coefficient is positive and the degree of this polynomial is even, then it's going to look something like that. Now, the higher the degree is, the more likely you're going to have curves. You're going to have turning points like that. But as far as the ends, that's what we're figuring out here. The ends are both going up when it's a positive leading coefficient, even degree on the ends. Once you get past all of these turns, however many you might have, it's going to be going up. So we know that. We at least know the graph is coming down like that, and then over here it's going to be going up like that. Now, what does it do up here? Does it come down, up? What does it do? Well, that's where we're going to look at the graph on WebAssign. So let's do that right now. And so here you can see, so we have our function in WebAssign, x to the fourth minus 8x squared minus 9. And so we know that the zeros are plus and minus 3. And so if we look at these graphs here, so we have 4 possible choices. And so we have these two, and then we have these two down here. If we look at these two down here, this graph only has a x-intercept of -3. This graph only has an x-intercept of +3. So it cannot be either of these two. These two cannot be the right answer. That leaves these two. So what I usually think about if I was presented with this choice, this problem, I have to graph this function, don't have a graphing calculator, nothing like that. What's the difference between these two? So obviously they both have the same x-intercepts. But I guess there are two things. So another thing I just noticed, this one actually has 4 x-intercepts. Now, we did not get 4 x-intercepts. We only got 2. So it really has to be this one. But another way to tell, what's another difference between these two graphs? We have the y-intercept. Now that's maybe a little bit more obvious at first. We have the y-intercept here is positive. The y-intercept here is negative. That's a very obvious difference. So what is the y-intercept of this function? Plug in 0 for x. You get 0 minus 0 minus 9. So the y-intercept is negative, which also points to this one. So you have two easy ways to tell. We have this one has 4 x-intercepts, whereas we know this function only has 2. And then the y-intercept here is positive, but we know that the y-intercept of this function is negative. So that's one thing to kind of be proficient at, especially when you get to calculus. You can save yourself some calculations when you're doing certain problems. Um, if you kind of find little shortcuts like this. So we don't need to plot any more points. We don't need to, like another difference is this bottom part here comes down, but it's say -15. This bottom part comes down and it's -25. So that's another difference, but that's not easy to tell just quickly. So finding those little differences in the graphs, once you kind of narrowed it down to two choices, is a quick way to do it. And that will be a good idea to figure out little shortcuts like that as you move up through calculus and things like that. So if you have any questions or comments, or you want me to do any other problems, feel free to leave those in the comments, or you can send me an email if you got that.